Hey, welcome everyone to this month in AWS Electronics. If you joined us last time, welcome back. If you didn't, then look, you're in for a great session. So I'll just do a quick round of introductions on our side, just so you get to know who we are, and we'll get into it. So I'm Chris Sorden. I'm a solutions architect at AWS. I help support customers in the high tech space, and yeah, I'll pass it over to Brian. So quick break.
Everybody, I'm Brian. I am also a solutions architect on Chris's team and Krishi's team, working with consumer electronics customers. And yeah, really excited to continue on this journey that we have been, showing you how smart homes could be designed and maybe building out the application for you today. Yeah, Krishi.
Hello, everyone. I'm Krishi. I'm a solutions architect. I work on Chris and Brian's team. Support customers that are trying to modernize their applications, their smart home applications. And yes, hello to any returning viewers, and hello to any new users. And let us know where you're chatting from, and we'll get started.
Yeah, definitely put in the chat where you're chatting from. I'm actually in Florida right now. It's raining like crazy outside, but yeah. So our session today, just so you get to introduce to AWS consumer electronics. Right, we don't just talk about cloud. We really try to bring down concepts to earth. So you know, last time we talked about connectivity between your smart home devices to AWS cloud. And each episode we're trying to bring different concepts of IoT, AI, and this episode will be focused around mobile architecture with like the right mix of depth and AWS white papers or practical use cases that actually make sense. So last time we actually had people that already have their own personal labs and trying to build out their own smart home type appliances for their own house. So that's exactly where we're trying to bring it down to earth and showcase to you how that's actually possible from an AWS perspective. So yeah, that's really the overall pitch as to why you would want to join us for future episodes and what we're going to be discussing today. So just to recap from episode 1, we went through and kicked off a journey of what it really meant to make your home smart, right? We laid out some key requirements around your HVAC, your energy units, your locks and cameras, and emphasize like that these things, if you were to be able to create them within a smart home type of use case, reliability actually matters. And we drove into the architecture here that Brian is pulling up, right? So just quickly speaking, IoT devices, they talk to like a local gateway, in this case a broker that's running AWS IoT Greengrass, and then from there it's sort of buffering your messaging requests, and then essentially being able to help with taking in your messages and relaying back to where they actually belong in terms of services to do things that you want to actually do, whether that be turning on a light, whether that be some sort of monitoring to be able to handle like any type of request within your smart home. And even there was comments last time around like, how can I build my own type of pet monitoring to be able to feed my dog when I'm away? So like these are all types of things that we want to be able to essentially show to light on AWS, and these are things that like we want to be able to show how things scale too, because scale is real here. Like one home we had mentioned might send like 25,000 messages a day, but just think of your home and think of every home in your neighborhood. Like think about how many messages are being sent per second, and that's really where AWS comes into play to be able to help with that scalability, help with that build. So yeah, let's go ahead and get started. Anything else from you and Brian and Krishi and last time that you wanted to discuss before we get into this episode?
Yeah, I think last time we were kind of just sketching out end to end what it looks like and kind of touching on what people care about in their houses. Like, oh, I've got my smart blinds, my temperature control, my lights. Maybe I want to organize them in environments. And then on the other end of the spectrum, we're talking about the enterprises that are building these platforms that can support all these things. And so it's a very high level look at, oh, well, we ingest data from the consumers into the platform and then can run analytics to understand how we might inform product decisions and things of that nature. I think today we're going to be a little bit more in the weeds of what exactly could the application do and what does that look like. And maybe if you're building your own home applications, it might inspire you to build something on your own. Whoops, I'm going to get that off.
Yeah, no, that I don't have anything to add, but excited to see what we build.
Cool.
Yeah.
You sure you don't want to take that call, Brian?
Nah,
But
it's good.
okay. But yeah, so today we really want to focus in on, a smart home really isn't smart if it doesn't connect to what we use on a daily basis, which is our mobile phones, right? So that's what we're going to be zooming in today, zooming closer to our phones, connectivity via mobile applications. How can we actually use a mobile application to be able to connect and talk with not only our devices, but of course the downstream services on AWS to be able to make the magic happen, right? So yeah, we'll go ahead and get started here in terms of overall. Brian, how do we want to do this? Just go through like step one of the diagram.
Yeah, I mean, maybe like before we do that, we could even kind of like think about some of the requirements of what we want the application to do.
Yeah, sure.
Some basics. Yeah.
Yeah, sure. So requirements speaking, feel free to put in the chat, types of requirements they would want sort of a mobile application to be able to do that's connecting to these downstream services on AWS to help with your IoT smart home applications. It could be anything. It could be, no, last time we had so much chat participation, so I was hoping for more. So, but it could be anything like just turning on your lights, adding maybe onboarding a new device to your overall stack. Firmware updates is always big, right? If you want to be able to go through a smart plug type of firmware update, these are the types of things that you expect to be able to do within your mobile application that actually require some type of user interaction from your perspective, right?
I want to be able to change the colors of my bulbs and do it like a light dance to music.
Light
Yeah,
dance.
yeah.
Oh yeah. Okay.
That's great.
Make light dance.
Yeah, it's going to be a party smart home.
Yeah, and I think as we're thinking about these requirements, it's nice to know. And then in the back end, we should always think about, okay, if we were to do this, what would the message look like that we're sending out to make this happen? How might that get processed? And then how might we design all the APIs to be able to handle it? We might touch on some good practices for building that out today. So hopefully it's an educational stream. Feel free to ask whatever questions you want or throw in a curveball. We're happy to accommodate.
Yeah.
Close my garage door. Oh yeah, that's a good one.
Great, yeah. Because if you really think about it, all these things are different physical devices, and these different physical devices might interact with different protocols, right? So smart lock might interact with a Zigbee protocol versus a light switch might interact with BLE. So when you think about all these functional requirements, it's very important to what Brian mentioned. Think about actual protocol, the actual messaging layer underneath, and how that could actually play in a role for building your API, building these types of applications downstream for streaming and batch processing, right? Because ultimately, at the end of the day, you want something that can be able to handle that translation for you, so you can have your mobile application talk to and connect to these services. Okay.
Yeah, and one thing about the close my garage door after I forget, I'd be curious about like, how would it know if I forgot?
I mean, video, radar, sensors.
So like, if I knew that it was open and I was far from home, I might send a message that's like, garage door close, right? There's probably like an API call for that room if we want to like genericize it. And then if you forget, I think that could be like machine learning. Like it over time, it learns what you want to do and like behaviors that are correlated with each other. And then in that case, if it's open for a certain amount of time and there's no activity in other areas for a certain amount of time, maybe it automatically closes or not. I know it can be, there's a lot of edge cases there where you might want to leave the garage door open all day and you want to take naps and have it open. And it would be annoying if the model did not understand that case, but edge case.
Yeah, 100%. And to my point earlier, in terms of being able to, all these devices might not necessarily exposed to like easy to use HTTP APIs, right? So within your mobile application, you would need something like an edge broker, where we had mentioned last time around being that type of traffic controller to be able to handle these types of messages, these types of requests, specific requests like closing your overall garage, to be able to act as that translator layer for messages, to be able to say, okay, even though it's a different sort of protocol stack, we can be able to talk to each other, interoperate, and then from there do what we want it to be able to do, which in that case would be closing the garage when we're not there, based off of the string universal semantic of what we wanted within the request.
Cool.
And yeah, starting to see Brian drawing out here very eloquently onward in terms of our devices, our smart home devices, being able to connect to that overall edge broker. But actually, it's important to note too that there is a concept of local control as well, right? In some cases, if your phone is on the same network of your devices, the mobile application can talk directly to that device via like a local control, right? So that means faster response times and no cloud dependency for those certain use cases, right? It's only super useful if if you're at home and you want to just manually be able to turn on a light, right? But as you scale and as you want more of that automation framework, those sort of batch processing to be able to be alerted when maybe your stove is turned on, when maybe like your stove is turned to there's an anomaly within your overall stove detection or whatever it may be. That's really where the edge broker comes into play, to be able to handle more of that messaging layer. So you can be able to have that correct setup in terms of that more resilient control. And then from there, yeah, so you see here, devices can either go to edge broker or just strictly to the mobile phone application. But for the most part, to be able to talk to the AWS cloud services, you overall need that edge broker to handle that overall scale reliability of what AWS can be able to provide. So picture of inside fridge. What was it?
Yeah, first of all, hello from the US. I think somebody's coming in from India. Thanks for sharing your location. And second, it looks like somebody came up with another potential
Computer vision.
Yeah.
Computer vision.
Yeah, you gotta let them know you really love oranges for this to work.
Yeah, that would actually be good for like a smart fridge, to come up with like a grocery list. So that's another like way how machine learning can help add functionality to your smart home appliances. It's a good one.
Yeah, and I know we're talking about at least in our scenario, it's more the application is kind of the interface that you're using to talk with all these different smart devices in your home.
Yeah.
There's definitely products out there like smart fridges that have everything built in, and they've even got the screen of their own. So one of my friends has a smart fridge, and it has that type of thing where you don't have to open the fridge to see what's in there. I know when I first thought of that concept, it's kind of strange, but then it learns like where you put things and when things are about to expire. And I think that's actually one of those interesting use cases. It's like, oh, like for people where they're not as diligent as others about throwing stuff out when it's about to expire, it's really valuable. And I could see like workflows jumping off of this, like, there's things I like to reorder often every week. And so if you had computer vision, there's like one less thing you have to think about.
Yeah. What's something that you like to reorder, Brian? So
yogurt?
I want to put you on the spot. Okay.
I do a lot of yogurt.
Yeah.
Yogurt.
Yeah. Great team here. But okay, going back to the diagram here, right? So essentially now once we have a request, we have our mobile application, right? We actually start to want to expose our application, our requests to physical services or services within the core app logic, right? So that's really where we're exposing APIs via let's say in this case a gateway, some sort of gateway that's acting as an authorizer for our front door from our mobile application to our backend services, right? So in this overall case, as Brian's drawing out here, yeah, we'll have a gateway authorizer. So that's going to help with overall signing in to your application, since you're dealing with a lot of sensitive commands when you're dealing with anything smart home related. So just think, unlocking doors, turning off alarms, even if your kitchen is smart home operated, like maybe turning on and off a stove, right? So you have to know really if the user is allowed to be able to access a certain element with your home. Was that flavored yogurt? But yeah, and you have to make sure that you get the proper permissions to be able to control the device for the overall scene. So this is really where that gateway authorizer comes into play for that overall sign-in aspect before the mobile application, before the user actually gets to the core app logic, right? So, and we'll dive into what services specifically AWS enables this, but just we're going to go through a quick workflow now of the
Yeah.
mobile app to device control flow.
I think there's like a couple pieces of security. So obviously data is encrypted in
Yep.
transit, but then once the message that you're sending is going through, you have to understand, does this person have the right to make these changes to these resources? Because as much as fun as it would be, I wouldn't want Krishi to be able to like turn my lights off and on or make them dance while I'm at my
Yeah.
desk. So that's why we have the front door.
And also, we need to make sure that there are boundaries between how we're enforcing requests. We can't let Brian see what Chrissy's doing on her device, because he might be able to have intel on when she locks the door at night, right? So these are types of things that have to be enforced from a tendency, like boundary perspective as well. And that's all handled within the overall gateway authorizer layer before we actually get into the bulk of what the mobile application wants to do, which is the core app logic, right? So yeah, the core logic, that's really what's helping to be able to do certain requests based off of, let's say, a get and post request. So let's say you're trying to fetch current state of your smart home, or even triggering actions of turning off of the light, right? So you'll be able to call upon certain APIs within your core application to be able to do these types of requests, like dimming the lights in my kitchen to 30%. Right. And there's a lot more things you can be able to do just based off of simple get and post commands as well. Right. If you wanted to be able to onboard new smart home devices to your home, you can just do a quick post devices command based off of whatever device it may be. So in this, let's say onboarding a new smart lock. Right. And then also we had mentioned before, some of the technical requirements was being able to do firmware updates. So you can also do a post request there via this overall core app logic to be able to not have to worry about this, or not have to worry about that smart lock not turning on due to like a firmware update, right? So all these things we'll get more into best practices as well, but that's going to be encapsulated within the overall core app logic, and we'll get into how to be able to really design that in a way that's scalable and in a way that's crucial for you to be able to improve upon and reduce latency. Because there's a lot of things within that overall layer that you can do in terms of rate limiting and in terms of just additional optimization to make sure that you have like good, what we call API hygiene for all of your devices that are going through. Brian.
As you were talking, I was like thinking about, we want to design APIs as well. And these are some good examples, I think. Let me know in the chat if I'm really wrong, but one of the ways that you could try to maintain good practices and be consistent would be saying like, okay, Chris mentioned that we want to add a smart lock, register a smart lock. A good way to design APIs is to think of them all as nouns, because when you do like a HTTP method to like post something or to get something, those are actions. And so if you design it in this way, you can always be like really consistent and say, I want to do an action, but I want to do it to a noun. So I want to register a lock. So I just keep going to the devices API and say, I post a message and I register a lock. And it's also good to have versions in front of them as well. There's different ways to do it, but this way, you know that once you set that contract of this is what a message looks like, and this is the structure of how I register a smart lock, I always have this format. So people, when they build applications or modify it, the logic, they'll know that this structure won't break. And then if you release like a new version because you added more capabilities, or change the structure somehow to make things faster or meet or mix better with the rest of the APIs, you could have V2. And so people could use that. And it has backwards compatibility. So just some things to think about. And then last thing I want to say is like creating the rooms, right? So maybe I want to create living room, or maybe I want to create kitchen environment, which is a different collection of devices. One way that you can do that is like, again, it's a noun, rooms. And then if you have my room ID, that's like something that can happen on the front end. So like I just registered room, my living room, BLT. And so that gets substituted here. So you wouldn't create like a hard-coded endpoint that's like this specific room ID. You would just say, I always have the rooms API. And as long as you follow these conventions, like perfect, we can create an environment just like that.
Yeah. You want to be able to have just the endpoints where sort of universal semantics, and then from there, you can always append and adjust if needed, while still maintaining, proper code control and whatever CI/CD pipeline you might be using. But yeah, thanks for going through that, Brian. That was really helpful. And from this core app logic, we're going to take. We obviously need some sort of means to be able to store like store the data, like store some of the metadata that's coming from the devices, from the scenes, right? So you'll have, as Brian is drawing here, you'll have a scene store layer, or you'll use a type of storage or type of database to help store that metadata and help store optionally like large versioned data that is coming from all these devices and these requests, right? But also, that's just for storing like data, but you also want to be able to have the bulk of what you initially wanted your request to do, which is more like real-time alerting, more sort of streaming and batching requests to be able to come back to the application and alert you, or trigger an automation where it's able to turn something off or turn off or close your garage based off of certain criteria metric, right? So you're going to have that core app logic starting to roll downstream to in IoT to like an IoT engine, right? So you'll have real-time updates. You'll have the application connecting via like a WebSocket, like an MQTT WebSocket that's helpful for more of that like hub sub protocol for your IoT devices, right? So this is going to help enable you to have that push style alerts and to have the actual state change between, if it's off, if it's on, if it's open, if it's closed. Right. So yeah, that's really where we start to say. Yep.
I'm gonna steal our last diagram and just paste that over.
Yeah, it's very similar, anyways. Yeah, the overall path is that your request is being picked up by the IoT engine, and it's routed to an alert service, and that alert service will invoke, a function, and from there it's going to provision or process back that message, and then try to notify back the user. Right. So that's really what, at the end of the day, we want our mobile application to be able to do. We want to be able to send that request in, either store the overall data behind what's happening, making sure that everything's being monitored for us within the application as well, but also get the response back to be able to have those real-time updates, those real-time analysis of what actually happened, trigger those responses back to me, the end user, that put in the request. But in some cases as well, you might not want your mobile application you might not want to be the one that's like triggering a request. You might just want there to be an automation element around a certain message that goes from the edge brokers directly to the IoT engine, right? So there's no like human interaction there. So that's really where the second portion of the actual application, the flow, comes into play, where it's more so edge broker to cloud, in this case, AWS cloud, right? So the app itself, the certain message will be invoking and going directly to the IoT core to be able to use for like streaming or batch processing, right? So this is very important in terms of more of like an automation type perspective. If you want to keep a hourly type of score of your smart home self, that would be something that you don't necessarily have to be able to trigger yourself manually on the app. That would be a type of API call that goes directly from the edge broker to the IoT engine to be able to facilitate that type of ingestion path. So yeah, Brian is just eloquently putting on the diagrams here, but I'm just trying to talk through as he draws it out. Um, anything else? Anything else you wanted to add to that perspective? What I was mentioning.
I don't think I'm trying to figure out how to get our alert service to get back to our mobile phone nicely, because I know you said a lot of good stuff about, oh, if you have open WebSockets so that you can have like open communication and have some sort of subscription process. I just
Yeah.
wanted to be able to cover that as well. So for example, like in the last episode, people were asking about, well, I want push notifications to my phone for certain things that happen. So in your application, you should have some way of subscribing to or like creating alerts for certain devices for based on certain status or something like that. So I want to be able to represent how we have an alert service that took in a lot of information, and with AI ML somehow it knows that there's some sort of issue and that you're subscribed to that issue and that we can send something back. So maybe if we use a different color,
Yeah.
we can have the alert service send something to a topic that's in the IoT engine. Oops, that's the wrong color. And I'll just use orange because we love AWS and we love the AWS colors and the branding. And show that reverse flow of our message being published to this engine. And we have MQTT over WebSocket connection here, and that is how we're subscribed to that same topic, which is, I want to know when some threshold is breached on garage door open and send an alert, push notification back.
Yeah, and it's important to note that this will all be delivered in real time back to you on the mobile application, right? It does us no good if it's alerting us 5 minutes after it happened, right? So anytime there's a leak detected or like a thermostat spike, we'll be able to go through this pub sub type of request to be able to process the content, and then from there, understand the context as well of who, when, like how it was processed, and then from there alert back to the overall user in real time to be able to update you instantly within your mobile application. So yeah, good call out, Brian, to be able to add in that point back to the mobile application, right? So even whether you're not at home or whether you're across the country, right, you can still stay in a loop instantly, and that's really what we want when we build these types of applications. When we want to be able to create an IoT smart home for our homes. Right, secure, scalable, and alerted in real time if needed.
IoT, and then we're assuming we're going to be using like AWS IoT services to handle a lot of the plumbing and heavy lifting of scaling and establishing topics and being able to have like a pub sub that's you don't have to implement yourself. So we just assume that we're going to have these topics set up and ready to go.
Yeah.
Has anyone used IoT Core or any of the AWS IoT services before, or was watching? Has anybody built a smart home?
One's in the chat if you have. Two, if not, stay silent if you're unengaged. Probably shouldn't have said that third one.
But yeah, I'll break the silence here. But yeah, it's important to note as well that because we will be using more of a fan out. There's a comment. Because we will be using more of a fan out approach, we can be able to have the optionality to be able to be alerted within your mobile application, within your email, within SNS, and also connect other systems to be able to be alerted via that same topic, right? So if there's supplementary solutions that need to be alerted based off of a certain threshold, you can be able to pair those optionality, pair those solutions based off of this type of pub sub subscriber methodology that we'll get into when we dive into the AWS services. What else? So this is generally speaking the flow of mobile application to device control, and we talked about the overall core app logic, how you would be able to connect and authorize in, and then from there, the types of API requests that you can be able to make to actually be alerted and go downstream. Yeah, so now we can probably get into the AWS services specifically on how they help to be able to actually run this type of workflow.
Yeah, so for those of you who haven't used AWS IoT, it's a managed cloud service that allows you to connect your devices and be able to send data securely and easily to different cloud applications. So that's really what is helping power this like mobile phone application connected to our smart home devices. And like we're using specific features to be able to leverage IoT Core and publish messages to the cloud and give these alerts.
Yeah, great. So let's go ahead and think back to the beginning of the flow, and let's start to think about the actual service behind the flow here, right? So as we mentioned, you're going to have an edge broker that needs to be able to essentially act as like traffic controller to help with dynamic communication between different protocols. So we have a purpose-built solution that can be able to run within any embedded device called AWS IoT Greengrass. So this is really what's helping to locally handle that communication between different devices that are of different protocols, as we had mentioned, like Zigbee versus Thread, right? So your phone might not be able to immediately interact with those protocols, but your edge broker, in this case, AWS IoT Greengrass, that's running on an embedded device can, right? So depending on your overall setup, we're going to be using AWS IoT Greengrass on maybe like a Raspberry Pi, or see a lot of comments coming in, but Raspberry Pi or another embedded device that runs Linux.
I did put a QR code if you want to scan it. It is the documentation, but it does a very thorough job explaining what IoT Core does and some of the stuff we were hinting at, which is doing a lot of the managed heavy lifting for the pipes, which you may not want to do yourself. And it's a good way to just get started and experiment as well. Being able to push that data into a central place, set up topics, have subscribers, register some of your devices and manage them from one place, even in the console. So amongst other things that it can do, the service can go very deep, but I think that's good to have a basic knowledge of that. Also interesting to hear that people are studying for certs.
Oh, great.
Yeah. So which cert are you going for? Mike P. Funk.
Yeah, I would recommend getting the AI practitioner, or if you're studying for that one, or if you're new to AWS, I would say the AWS Solutions Architect Associate as well. Great one to be able to have, and I recommend that. But getting back to the session, so
we have a question around data privacy really quickly. So how is data privacy ensured, specifically PII, personally identifiable information data? So do either of you have really deep answers around the security? I can also tell you what.
I'd say the security is the shared responsibility model is the first thing that comes to mind, but that's not an excuse. We secure the infrastructure, right? But when you have the keys in your control, it's up to you to secure the keys and use them to encrypt the data. And once you encrypt them, only you can unencrypt them with the keys that you have. As for PII specifically, there's Amazon Macie, which is a AWS service that you can turn on, and it can look through your S3 buckets, for example, and look for things that look like PII data. And then you can try to redact them or identify them or try to do what you want to do. But a lot of the responsibility is you being able to classify your data into, I know when I'm ingesting data, I should only be doing it this way for certain things, and then when I store them somewhere, I should have different levels of classification. So, some things that might not be as important would be what's like not important information.
I don't
Maybe
know. Device ID. I don't really know. Like it's a number.
I would say like my birth date and my address would be definitely under, classification level 3, whatever the highest you have. But then something like, yeah, I was gonna say like what I had for breakfast this morning, but then that could be used against me, no?
that could be used against you.
I mean,
But it's
Right.
yogurt, so
Yeah.
well, I feel like, yeah, so if we're in the context of like data privacy when thinking about it for smart homes, I would definitely, agree with what Brian said about, how there is part of the ownership of responsibility lies with you. And then depending on how you're building the service, what services you use within AWS, some of that responsibility we might have already baked in. So it just depends on how it's built, but you want to keep the same things in mind as when you're building other applications that you've built on AWS. So like, how am I encrypting my data at rest and in transit and, like all of that stuff.
Medical definitely as well. So like HIPAA, you have to adhere to that.
Yeah.
It's called PHI, personal health information.
Yeah.
Separate from PII, but similar.
Yeah. Yeah, I just wanted to add as well, like we had mentioned Macy, we do have purpose-built solutions that can be able to integrate nicely with our solution here to be able to handle more of that hiding of the PII data, right? So if you really think about AWS, it's really just like infrastructure layer for a bunch of APIs. So everything we see here is interfaced via APIs. So with that being said, any service that's purpose-built for security, like removing PII data, can be easily called via an API to be able to handle that type of request within our overall architecture. So just know that AWS is very robust in the types of services that we provide, grading throughout the overall stack to make sure that overall request will be met. But yeah, great question. And let's go ahead. I wanted to jump into the overall mobile application and talk more about our Amazon API Gateway, which is our front door to our backend services, right? So I mentioned beforehand that API Gateway will be acting as that additional front door, and that's going to be enabling like rate limiting and like authorization as well. So within that overall sign-in process from when you get to your mobile application and you're going through the gateway and authorizer, so that's really where you're using API Gateway as that front door. But when you actually get to that overall authorizer piece, that's really where we introduced Amazon Cognito paired with a Lambda authorizer as well, right? So if you think of Cognito is a great service to be able to help with just overall making sure that you are who you say you are in terms of being able to get on. You do have that proper access to be able to do a sensitive command within the overall mobile application, right? And then that overall layer as well is helping to prevent like unauthorized users, helping to support like role-based access, right? So you might have kids that you might only want your kids to control one element of the house. So that's really where you can be able to have more of that role-based access control for that within your overall experience to make sure that your kids can only do this one specific task and to help enforce those boundaries across the stack, right? So API Gateway plus Lambda authorizer plus Cognito ensures that this all happens at the edge as well before any logic executes, right? So before any message is actually sent or executed across, you know that you have proper role-based access and all the unauthorized users are kicked off, right? And then from there, that's really where we get into the core application, the core logic. So this is really where, like if you're assigning devices to a user, if you're adding a new device to your house or just doing a simple API call, we'll be running in using AWS Lambda as our sort of core functionality service to be able to help with that overall scaling and help with being able to have that code, have that execution run, right? So good thing about Lambda is that it is serverless. So you only pay for when the code actually runs. So it's not as if you're having this running 24/7, even if you only want one specific task to be executed on a certain time based off of like your kids are going to school and you want to be able to turn off the lights, right? So and also Lambda is really purpose built for scaling. So whether it's you turning on lights or 10,000 devices trying to do like a nightly type of job cycle, Lambda will be able to spin that up in parallel, right? So it's really perfect for those event-driven type of triggers. And in this type of scenario, you'll have a lot of those type of triggers in terms of any type of user button being pressed or any IoT core device being emitted to a certain other service, right? So it's able to react and be very quick to be able to scale along with your overall needs, right? And then we also wanted to get into a bit of best practices around actually building the API. I believe, so Brian, you might have already gotten into some of that.
Sorry, I was trying to, you were talking about like the serverless stack, and then I just wanted to get a QR code out there. So although this blog post is not exactly the same use case, it has the same pattern of what Chris was talking about, of thinking about using serverless, which is more, there are servers that are running behind the scenes, obviously, but a managed service to kind of take the heavy lifting off. So you can try to focus on the application code and then tune the scaling without having to manage clusters of services or trying to create like horizontal scaling, auto scaling groups, and trying to spend a lot of time building the build scripts and really focus on the logic. So that would be the advantage of going with this route. The trade-off is maybe you have a little less control when you start, but if you're really focusing on just trying to get stuff to work, I think serverless is a good way to start. Yeah, just wanted to get that out there, and I'll leave that up for now. Meanwhile, I'm trying to make all the icons fit. It's getting crowded. Sorry.
I also wanted to add that sorry, go ahead, Christian.
I'm just answering the question somebody's asking. Is Cognito, Lambda, and S3 all serverless services? Yes, they're all considered serverless services. So,
yeah, and I wanted to add that these might seem kind of abstract right now, but AWS really prides us on allowing you to be able to play around with these services and spinning up a quick test account. So if you are interested in playing around and potentially doing like a quick POC of a certain IoT device, maybe even if you don't have like a embedded device at home that you can use like just a VM or a local computer for a testing purpose. Like feel free to sign up for AWS services and play around with some of these purpose-built services to see how you can actually create that IoT core and start simulating and transmitting those messages over to an edge broker, and then from there how it runs downstream, right? So we do give, I think there was an announcement last week where we do give $100 in like free plan credits for just signing up. So always like to avail of those type of credits, just even if it's as simple as running a Lambda function, so you kind of understand the scope. And it goes well if you're studying for a certification as well. That's really how I was able to knock it out. I did a lot of building and playing around with services. So definitely wanted to add that. But yeah, back to the overall flow. So just a couple of quick things as well on API Gateway. It's really a great service as well, since we can do quite a lot with overall rate limiting, caching. If we need to be able to reduce latency and improve scale as well for a smart home, right? We can be able to help with caching, like the device metadata, help with caching like scene configurations as well. So this is going to help with that overall layer of making sure that your mobile application is responsive, is reducing the overall backend type of load on the application itself, and helping with just more uptime performance, right? So along with that, I did mention like rate limiting as well, so throttling all of those bad actors, right? So no one can be sending like 2,000 push requests to this one device to be able to try to throttle it to flood the backend for whatever reason, right? So preventing any type of DDoS attacks as well. This can all be done via sort of the API methodology, API architecture. Yeah.
About comment,
schizophrenia.
it's starting to look
Vulnerability.
like a event-driven architecture. I think we're
Yeah.
about to get to that when we get to the alert service, particularly. But depends
Yeah.
on where you want to go, Chris. It's
Yeah, let's get to the alert service. Along with just, I mean, just for the sake of going to the diagram too, we can use our Amazon DynamoDB database for storing data, and also S3. We can use DynamoDB for more of like that ultra low latency type of data, and then S3 for more of that like large versioned type of metadata that we would need that's coming from the devices.
yeah. So like,
Good.
I might say like, for the scene data, for instance, you might have like blobs that are just getting stored in S3. But then if you're, say, I want people to quickly like retrieve like the current state of my living room, you might want something like that. And then and obviously S3 over time, the historical state of your household might not be that important, so you can start, at least from the enterprise side, or if you're building it on your own, just start moving things into cold storage to save costs. Yes.
Yeah. An example is like if you want to register a new device, you might do like a post device onboard type of API call, and then from there it's pulling the DynamoDB backend to be able to make the request back. Right. So that's really more so from the scene store perspective of just storing that overall information and for you to be able to pull based on when you do API calls. But now let's go into what we're getting to now, the event-driven architecture with the alert service and also the streaming and batch ingestion. Right. So as we had mentioned, we want real-time updates. Right. We want those motion alerts. We want to be alerted anytime a door opens for whatever case it might be in your home. Right. So this is really where the app is connecting via an MQTT over WebSocket to AWS IoT Core as well. Right. So this is way more so.
Sorry, I'm trying to find the. So for the viewers, I have a PowerPoint that has all the latest diagram colors. So I'm just frantically looking through to grab the right icon to throw on the picture. So that's why I'm all over the place.
Sorry, I'm on one screen today, so I normally would have been able to draw it out while I'm talking, but apologies. But thanks, Brian, for
all good. I got two screens, but if it bothers people that I'm flipping my head back and forth, let me know in the comments.
So yeah, let's talk about this alert system, right? Let's say that we have a real world use case where just imagining someone is unlocking your smart front door. Right? Within a second, you want this overall device lock to report it to the broker, to report it to IoT Core, right? And then from there, a message will be routed to an alert service to be able to deliver a real-time notification, right? So at the end of the day, if the smart door is unlocked, what you want back is your mobile application saying front door was unlocked by Chris at 1:19 p.m., right? So whether the app is open or not, right, you want to be able to have the notification back. So this is really where we're going to start to see this fan out approach, right? So the message will be picked up by the IoT engine, let's say the message of the door being unlocked, and routed to this alert service, right? And then AWS Lambda will be pushing that message to, I'm still on the alerting service, but pushing that request to Amazon SNS. And then from there, we can be able to trigger those real-time push updates back and optionality have text SMS type requests back, other systems that need to be alerted, right? So this is really starting to have that event-driven architecture feel for being alerted in real time based off of a certain type of request or criteria that you set out for it when you made that initial request.
Yeah. Let me just do this real quick. AWS SNS. And I think one other thing, even though we want to keep things as simple as possible, but one option we have in our back pocket is to use like SQS. So say we're having a lot of challenges with scale and data's coming in too fast for us to like process it, and we're not quite sure how to scale out. one thing that you can add is like a queue. So then you can get a lot of messages to show up in the queue, and then you have something that can process them off. It may be a little
Yep.
bit slower, but you may be able to, handle the short-term scaling issues.
Yeah. And let's move into more of the ingestion and processing piece. So we just talked about like that real-time alerting that but as you had mentioned, not all telemetry or not all data would need to be routed or need to be made a request from you, the user, on the mobile application, right? Some device telemetry like power usage or like temperature of a thermostat, that can be routed directly from the edge broker, which in this case is IoT Greengrass, directly to IoT core, right? So that's going to be triggering and being routed directly to that IoT core. So from there, we can set proper rules, that proper business logic without a user actually putting in a request, without a user actually putting in a command, right? So it's more automated in nature, going more into the setting data downstream from specific telemetry data to be able to create more of that long-term intelligence for your overall home, right? So this is powered by AWS IoT core, right? Since within IoT core, you can set rules. We do have a rules engine in place where you can be able to have more of that routing, like messaging routing, to actually make the full logic around what you're going to do with this power usage once it's here, what you're going to do if the temperature spikes above 90 degrees on a summer day, right? So these are all things that you can set rules for to be able to match these type of messages back. And then from there, it's going to make a decision, right? It's going to make a decision if it goes through a streaming ingestion workflow or a batch ingestion workflow, right? So if you don't know, batch ingestion is more so for less urgent data. Like a good example is if you want hourly summaries around what's happening in your house, that might be a batch type workflow versus something that you need real-time processing for via streaming. So did you want to handle that question? I saw a question pop up, but
it was just a comment.
Okay.
With the queue, we can
Back
handle
pressure.
that for sure.
We love to hear those terms.
Oh, yeah, great. So this is where Brian is drawing out that decision flow, depending on the rules that are in place, depending on the actual use case of if it's urgent data, like an hourly summary or telemetry logs, versus something that is like alert-driven processing. We hear some cops in the background, like something something that like needs real-time assistance and processing, right? So that's also great for real-time dashboarding too. So for streaming ingestion processes, we have Kinesis data streams. So you can think of Kinesis data streams acting as that that layer for
It's
exactly.
like a pipe.
Yeah, exactly. And then from there, you need to stream that data somehow as well. So we do have AWS Glue for like an overall streaming, extract, transact, and load that data for streaming, along with if it was a batch process as well, you would still use that overall same flow. You'd still use AWS Glue to be able to do batch jobs within the overall data, but now you'll be using Kinesis Firehose. So if you're studying for the certification, for the SAA certification, just know the differences between the two. I know there's a lot of questions on that, on like streaming versus batch, and like the types of flows of how it differs based off of like going from Kinesis data streams to AWS Glue versus Kinesis Firehose to S3 to AWS Glue, right?
We have a question from La. Sorry, I can't pronounce that. GS1. Sorry. How is it protecting privacy when it is listening 24/7? So in this case, we're assuming that if you build something yourself, you obviously control everything. If you're a platform provider, typically there's going to be some EULA, like what's the EULA stand for? User license agreement. It's like what you have when you sign up for services. So I would have to read through that and opt out of anything that you don't want it to have control over. But typically, like a good practice would be that you're only able to see your data. It's encrypted with your keys, and if you don't want them to look at your data, then you have to check. Oh, it looks like some people recognize each other here. Great.
What do you mean?
Rob? Where is Rob?
Oh, where is Rob?
Where is Rob?
That's awesome. We got buddies in the chat.
Also, I think somebody mentioned encryption. So, yeah, I mean, having encryption in transit can help you protect your data as it's getting into the cloud. It's a good point.
Yeah. So, and we're coming up on time here, but I just wanted to go through like a real world example of, let's say, when you would use Kinesis data streams. So if you had a smart plug or like you're tracking to see how much energy your heater is using, that telemetry data from the smart plug will be published via a MQTT sort of stream to be able to go back to that cloud metrics and like power usage, right? So that overall quest is going to hit the IoT core here that we see within the IoT engine, and that's going to forward forward it via Kinesis data streams to the streaming ingestion pipeline, right? Since we want this to be loaded in real time to kind of understand how we're tracking the overall energy. And then from there, we'll have AWS Glue transform that overall raw data into maybe converting it to a certain type like watt seconds to kilowatt hours and tag that with a certain metadata like user ID type, right? So have more universal semantics that we can be able to push for analytics further on, right? And then these final metrics can be stored in something like S3 or Amazon Aurora, depending on the type. And then from there, we can do a lot of cool stuff with dashboarding, powered analytics of additional ways in which we can be able to have a flywheel effect of how we're building our model now with analytics with like something like Redshift or Athena, right? So ultimately at the end of the day, like now from that overall pipeline, the homeowner can be able to open up their app and see that the heater was using this amount of kilowatt hours per week, and it's up 2% from 2 weeks ago, 3 weeks ago, right? So now this is really where we're trying to build that event-driven type of API architecture into like historical record that's enabling a lot of cool things when the data is actually there sitting in the data store. And I think that's a segue to our future episodes of what you can be able to do from an ML AI perspective of like anomaly detection, of like energy optimization even further, right? So yeah, it's all about making your smart home better, audible, and more explainable to you and to anyone that's going to your house. So I think that was all we had to cover today. I just wanted to try to segue to the next episode for 2 weeks from now. But
Oh yeah. Okay, we can talk about that. So yeah, I won't go into this, but essentially I was trying to draft out like what a message would look like. Device okay, device okay, device okay, device not okay, and have stamps and stuff like that. But I think for the next episode, let us know what you want to see. We're thinking about having an IoT specialist come in and show us their home lab. And another episode would be actually going deep on the AI ML piece. Krishi, if you want to take that one on, that would be great. And AWS certs available for everyone. Anyone can take it.
Yeah.
It's open to everyone. Yeah.
Yeah, there's actually a promotion going on where you can get a free certification. I found it somewhere the other day. If you avail of, let me find it real quick before you drop off. AWS Educate. All right, let me just send this. Well, we can send this over. But if you join via AWS Educate and learn on AWS Skill Builder, you complete the prep course, you can be able to get a free voucher for any certification on AWS. So I definitely recommend availing of that if you haven't already. And yeah, I think this session today.
Wait, what was it called?
AWS Educate. Can I send it right now? I'm not sure.
Oh, thank you. Somebody sent it.
Hey.
Yeah, AWS Educate. Do the Skill Builder course, get the points, and get your free voucher. And hopefully today's session helps you with some of the concepts around data processing. And these are concepts that are on the Solutions Architect Associate exam. So hopefully there's some value there as well.
You do not have to be enrolled in an accredited college. That part's up to you, but anyone can take it. Yes. Awesome. I think we're at time. Thanks everyone for tuning in, and hope to see you here in a couple weeks.
Thank you.
Bye, everyone.